squared inequality. And so what we're going to do is square the AM-GM inequality to facilitate a solution. So I'm going to multiply by 2 and then square both sides. That'll lead to a plus b quantity squared. A plus b quantity squared, which is the form right above us there. Okay, now what we're going to do next, we multiply by 2. So when we square 2, we'll get 4. So we have a plus b quantity squared is greater than or equal to 4ab. All right. And it makes sense that we do this just to make it the AM-GM inequality fit the above inequality, or the given inequality that we're trying to establish. Okay. Now, y'all, for the AM-GM inequality, equality holds only if a equals to b, which is not the case here. Okay, square root of 2 is not equal to the square root of 3, and so that's why we can drop the equality portion of this inequality symbol. Okay, so this right here would be, according to this result right here, this would be greater than 4 times root 2 times root 3. All right. Now that's an awful long ways, it appears. Look, I mean, up here we have a root 3 and then we have 164 over 29. So what in the world are we going to do? I mean, it doesn't look like this has done us much good. Now here's where we have just a little bit of a skyhook. Now I'm just going to write this down, and I'm not that proud of this, but it does work. Notice that, and let me just come down here where we have some space here. 41 squared, and I'll try to, hopefully you can see why I'm trying this. 41 squared over, and this took some time right here, just some guessing and checking. All right, and I don't know of a systematic way of doing it really, but notice this is a very square rootable object, right? If you take the square root of this, you get 41 over 29, you know? Now, so the reason why this is important is because this is equal to 1681 over 841. Y'all notice that 2 times 841 is 682, right? And so you can see that this object right here is definitely less than 2, right? Now again, y'all, just a lot of guessing and testing here, knowing that I needed something squared over something squared. All right, but notice that this implies what? That the square root of two is greater than 41 over 29. All right. Now again, I'm not claiming to be proud of this, but that is a fact, right? If you trust the arithmetic that I did over here, this is true. This is just a little, 2 is just a little bit larger than this, because if this were 1682 divided by 841 would be equal to 2, right? So this is strictly less by a little bit than 2. And so when you square root both sides, you get the square root is greater than the square root of this, which is 41 over 29, okay? But notice what that means here. That means that this is equal to, or well, we can say greater than, right? So this is also greater than 4 times 41 over 29. Okay, times the square root of 3. Okay, folks. But notice when you do 4 times 41, you get 164, and that is equal to 164 root 3 over 29 over 29. All right, folks, and notice that is what we were trying to prove. All right, 164 root 3 over 29 right up here. Okay, and again, everything, I'm happy with everything other than this part right down here. Again, not proud of that, but it's kind of like, 22 over 7 is a rational approximation, and you can work through why that's true. And it's similar, you just kind of have to scratch around to figure out 41 over 29 is a pretty tight rational approximation. Now, so just something I probably should have mentioned up here, the A and the B are supposed to be greater than 0, I believe. It has to be, and that's not a problem here because our A and B are greater than 0. All right. And also, just at the beginning, I probably should have said something like this. The floor of 164 over 29, the floor, y'all, the greatest integer function, okay, that's equal to 5. And that would have been probably a good motivational thing to say at the very beginning. This is equal to 5. And that's because 5 times 29 is 145, and I think 6 times 29 is 174. So you see the floor of this is 5, the greatest integer, less than or equal to it. And notice right here that the square root of 2 squared is 2, square root of 3 squared is 3, 3 plus 2 is 5. So you can see that this is a pretty tight inequality. And you may want to check it on the calculator. I think it comes out super, super close. But anyway, I hope you guys enjoyed that. And again, if somebody can think of a better, this part right here, does the trick. Once we establish that the square root of 2 is greater than this, we literally can replace the square root of 2 with something that it's greater than, okay? And we preserve the inequality, and that does the trick. So anyway, hope you enjoyed. Let me know what you thought.